All right, for example 4, we need to change each to rational exponent notation, and we're going to provide our answer also in radical notation. Now, yes, it is in radical notation already, but what we should probably write here for our instructions is, how about this? Simplify, right? The big word simplify, then change each to rational exponent and radical notation. There's a number of ways to do these. I'm going to give you the longhand way over here, and we'll kind of do maybe a little shortcut method over here on the right, just so that you understand what's going on though. The 10 is outside, so it's nice and happy. And if we were to write all of this out, this does get a little bit long, but hopefully it will make better sense to you. So the x to the third is x times x times x. Z to the sixth is z times z times z times z times z times z. A to the fourth is a times a times a times a. And we're going to have to write out a bunch of b's as well. Let's deal with the b's here separately. I'm just going to write b to the 11th. And I think we'll go ahead and use a pattern here at the end there, because it would just be too long to write all those out. Remember, when we take the square root, we're looking for pairs underneath, because the square root of x times x, or x squared, is just x. So if we can find a pair of values or of variables or numbers underneath a square root sign, we can go ahead and pull one of those out. So as a matter of fact, I'm going to go ahead and do that right now. One of those will come out. All right. And then over here, this x doesn't have a pair, so it's going to be just by itself. It's going to have to stay under the radical sign. For the z's, though, we could say, hey, there's z times z, z times z, and z times z. So how many pairs are there? Well, there's 3 of them. So z to the third power is what you can write on the outside. Z times z times z would be z to the third. Let's look at the a's here. And we've got 2 pairs of the a's, so 2 of those can come out. And we're going to do the b here in a second, but let's go ahead and do the radical sign. We've got an x that needs to stay in, and we now have to deal with these b's. Let's take a look at what happened here. Well, we had x to the third, so only 1 came out, and 1 had to stay in. And that's an odd exponent. 6 would be an even exponent, and 3 of them came out. A to the fourth is an even exponent. 2 of them came out, and the b's we haven't dealt with yet. Also, there should be a little 2 hanging out up here. If you don't see a 2 by a radical sign, of course it's a square root. But I want you to see what happens when we take 3 and divide it by 2. We get 1 with 1 left over. So here's your 1, I'll even put that there for you right now, and there's the 1 left over. 6 divided by 2 is 3, with none left over. That's why there are no z's. 4 divided by 2 is 2, with none left over. If we use the same rule with b, we need to take 11, divide it by 2, and essentially what you're doing here is you're just changing this into a rational exponent. And then we're gonna go ahead and do that. 11 divided by 2 is 5 and 1/2, or 5 remainder 1. So underneath, outside, we should have a b to the 5th power, and then a 1 will stay underneath, or b to the 1st power. If we clean this one up, we've got 10x z to the 3rd, a squared, b to the 5th, square root of xb. And I think I did this one a little bit backwards. I kind of did the radical notation first. So let's say that this is going to be radical notation here. And if we go back to the original problem, the original one, we've got 10, and then we've got all of these guys right here underneath in the underneath the radical sign in the radicand. And so we can say also that this would be 10. Remember, this 2 will become the denominator of a fraction, so this is x to the 3 over 2 power, z to the 6 over 2 power, and a to the 4 over 2 power, b to the 11 over 2 power. Yes, that's right, 11 over 2 power. So if you take a look at our original expression here, the 3, the 6, the 4, and the 11 stay in the numerator position, and the 2 here, what's out on the shelf, or the radical, the root, that's going to be in the denominator. We just need to go ahead and clean this up a little bit. The x to the 3 over 2 can't be simplified. The 6 over 2, though, is 3, and then the a to the 4 over 2, that's a squared. Move this up a little bit, hopefully that's not off the screen. And then this is b to the 11 over 2. So go ahead and simplify your fraction parts in the exponent position. And this right here, so we can actually kind of box this in. This is the radical notation here on the top. And this would be our rational exponent notation. So this would be our answer for the first one. So maybe it would have been better to do that first, but we got it done eventually. And you can see here that there aren't any radical signs. These are just rational exponents, and they're all simplified. For part B, we can do the same thing, and maybe I'll do this for you in the correct order, or at least what it says up here. So let's go ahead and do that, and then we're gonna go ahead and simplify it into radical notation after we've done the rational exponent part. So let's take a look and see what happens there. The -4 is outside, so just go ahead and leave it outside. Remember that if you have the base and then this power here, this exponent will become the numerator, and the 7, the radical or the root, will become the denominator. And we can go ahead and do that with all of them. So the 7 here is in the numerator, and the 7 goes in the denominator. T to the 16 would be 16 over 7. Simplify this a little bit. So -4 r to the 5 over 7, s to the first, or just s, and then t to the 16 over 7. We can't simplify anything there. And so this is going to be your rational exponent notation answer. That right there. And we can actually use this to help us find our radical notation. What you want to do is take a look at the top parts here. We're going to do something similar to what we did with that b to the 11th before. 11 over 2 is 5.5. Remember that the 5 came outside the radical sign, and then the 2 and the remainder stayed inside. So if we change this back into radical notation, we can see that the -4 is fine on the outside. The r to the 5 over 7, when we take 5 divided by 7, there is no remainder. So there will be nothing that comes outside here. Excuse me, the remainder is 5. I should have said that a little bit differently. There is no whole number, though. That's what I meant to say. There is no whole number part. So what we need to do then is, we can leave a little bit of space here, is we need to keep the r to the 5th underneath. None of them come out. You can imagine we need 7 r's underneath here, and then one of them would come out. This s is good. The s can come right out. There is no exponent here. You will not see any radical notation. 16 over 7. Let's take a look at 16 over 7. If we take 16 divided by 7, we get 2 with a remainder of 2, or 2 2/7. If we apply that to our thinking here, the t then would have a 2, it's the whole number, and then underneath the 7 is the root, or the radical over here, and the 2 needs to stay underneath. And this would then be our final answer in radical notation. And just as an instant recap, what happened here, just what happened here was we took these exponents that we saw, and we asked ourselves, if we did 5 divided by 7, would there be a whole number? And if there would, it needs to come out. 5 divided by 7 is less than 1. There's no whole number. So the 7 still here is in the root part, or on the little shelf, and then the 5 will go with the variable. 16 over 7, when you take 16 divided by 7, you get 2 2/7. So the 2 comes out and it stays by by the base here. And then what's left over will be underneath the radical sign here, t as t squared.